Good day, everyone. So for today, we're going to have our discussion in general chemistry too. So specifically, our topic is entitled electrochemistry, and right now we're gonna focus more of the electrolytic cell, Faraday's law of electrolysis, battery, and corrosion. So as you can see in here, this is just a continuation of our discussion last meeting. Um, it is all about electrochemistry. So if we're going to talk about electrochemistry from the etymology itself, electro, so always remember that the term electro is always associated with electricity or electric current. And then chemistry, again, it is associated with the interaction between reactant and product and the production of desired product. Okay, so with that in here, in electrochemistry, what we're going to synthesize is the electric current from a redox reaction or a reduction oxidation reaction. Okay, so that is for electrochemistry. Okay, so with that, here are the objectives that we need to attain as we go on to the discussion. So number one, we need to describe electrochemistry involved in some common batteries such as A, like large dry cell, B, button batteries, C, fuel cells, D, lead storage battery. Number two, apply electrochemical principle and explain the process of corrosion. Number three, explain electrode reaction during electrolysis. And number four, describe the reaction in some commercial electrolytic processes. Okay? Next, we have here the source of activity. So in here, redox reaction takes place in electrochemical cells to produce electricity. Explain why oxidation and reduction proceed simultaneously. Okay, so the reason why oxidation and reduction proceed simultaneously is it because we need to have balances in the transfer of electrons. So meaning to say we need to have balances in the number of gained electrons and loose electron. And that is the reason why it is called a redox reaction, meaning to say they need or they are required to proceed simultaneously in order to balance the transfer of or the number of electrons being transferred. Okay, so that is for the redox reaction. Next, we have here our study these terms. So in this module, you will encounter these important terms. Number one, electrolysis. It is the chemical change produced by passing an electric current through a conducting solution or a molten salt. So our primary goal in the electrolysis is to break down substances into simpler substances with the application of electric current. Okay, so next we have here the voltage. It is the potential difference between two half cells. It is also the amount of energy that drives a certain reaction. Okay, so next we have here the current. So this is the flow of electricity or electric charges in a specific device. So always remember that high voltage does not mean high current because there are devices that does not need high current or high electricity output that is being passed through it. Okay, so next we have here the corrosion. Yes, so this is the process or a natural process which converts a refined metal into more stable form. Okay, so let's say for example we have aluminum. Okay, so what we're going to do in here is that with the application of different substances in the environment, we're gonna be having a more stable form such as aluminum oxide, aluminum hydroxide, and aluminum sulfide. Okay, so that is for the corrosion. Next, we have here our overview regarding electrolysis. Okay, so by definition, electrolysis is the process by which ionic substances are broken down into simpler substances when an electric current is passed through them. So in the process of electrolysis, always remember that we are applying a non-spontaneous redox reaction. So always remember that a non-spontaneous reaction is a type of reaction that needs an external force or external sources of energy in order for it to proceed. Okay, so here are some practical applications of electrolysis. So number one, electrolysis is used to decorate metal surfaces. As we all know, let's say for example, metal surfaces or um, metal objects such as spoon and roofs is synthesized from a metal or specific metal. So it can be aluminum or iron. So yun yung ginagawa natin. We are applying electric current in order to synthesize those objects. Okay? So aside from that, electrolysis is also used in order to layer different metal surfaces. So we are layering different metal surfaces to prevent corrosion. Okay, so aside from that, it is also used in the electrometallurgy. So let's say for example, we have a silver necklace and gusto natin makapag-produce ng rose gold or ng gold na necklace. So ang gagawin natin dito, with the help of the gold plating, okay, so gold plating or rose gold plating, we will able to produce our desired product, okay? So with the help pa rin of electrolysis or with the application of electrolysis. Okay, so aside from that, ginagamit din natin yung electrolysis in order to separate water molecules in order for us to obtain hydrogen gas and oxygen gas. Okay, so aside from that, ito rin yung ginagamit ng mga astronaut para makuha nila yung oxygen from their oxygen tank. Okay? Again, we are applying electric current in order to break down smaller substances. Okay, so again, electrolysis, um, it is commercially or it is used most of the time commercially and industrially. Okay, so next we have here the electrolytic cell. So electrolytic cell is composed of a redox reaction system that requires energy to occur. In other words, the reaction occurring in an electrolytic cell is a non-spontaneous where the cell potential is always less than zero or simply it is negative. Okay, so always remember that electrolytic cell undergoes through non-spontaneous redox reaction. So kapag sinabi nating non-spontaneous, we need an external source of energy or external forces that will drive the redox reaction in order for it to occur. Okay? So with that, let's differentiate galvanic cell and electrolytic cell. So for the galvanic cell, this is a type of cell that undergoes through a spontaneous redox reaction. So kapag sinabi nating spontaneous redox reaction, so this is a type of redox reaction that does not need an external force in order for it to occur. So simply, this is a type of redox reaction that is freely occurring. So since galvanic cell undergoes through a spontaneous redox reaction, it produces an energy or what we call the Gibbs free energy. So the Gibbs free energy will then produce an electrical energy. Okay? So yun yung magbibigay ng energy to sa ating different devices. Okay? So next we have here the electrolytic cell. Okay, so in here naman, again, it undergoes through a non-spontaneous redox reaction. So meaning to say, kinakailangan natin dito na external force in order for it, or in order for the redox reaction to occur. Okay, so ang sources, external sources natin na energy can be a battery or it can also be a power outlet. Okay, so in here, ayun nga, kinukuha natin yung electrical energy from external sources and then yun yung nagda-drive para magkaroon tayo or mag-undergo yung electrolytic cell into non-spontaneous redox reaction. Okay? So, next naman, in terms of the half reaction, so in oxidation for galvanic cell, we're gonna be having here a neutral reactant and it produces a positively charged substance, okay? On the electrolytic cell oxidation half reaction, so we're gonna be having a charged particle and our end product would be a neutral type of substance or a substance that does not have a charge or simply it is an element by itself. Okay, so next we have here the reduction half reaction. So we have here both of the galvanic cell and electrolytic cell starts off with a charged particle as their reactant and it will then produce a neutral substance. for the overall reaction, okay, so in galvanic cell, we're gonna be starting off with neutral substances as the reactant, and it will produce a positively charged and negatively charged type of substance. On the other hand, in electrolytic cell, we're gonna be having here a positive, negative substances as the reactant, and it will then produce a neutral substance. Okay, so another thing is in galvanic cell. Okay, so as the anode serves as the negative electrode, and in the galvanic cell, cathode naman serves as the positive electrode. So in electrolytic cell, since we have here the application of battery, so with that, our anode here serves as the positive terminal kasi nga siya yung connected do sa positive side ng ating battery. And then sa cathode naman, siya yung nagiging negative kasi nga nakakonect siya do sa negative terminal or negative side of the battery or different types of power sources. Okay, so that is the difference between galvanic cell and electrolytic cell. So with that, let's talk about the electrolysis of water. So the electrolysis of water produces hydrogen and oxygen gases. So at anode, water is oxidized to oxygen gas and hydrogen ions. And at cathode, water is reduced to hydrogen gas and hydroxide ions. Okay, so in order to examine the electrolysis of water, we're gonna be using the Hobsman electrolysis apparatus or the Hobsman apparatus. So this apparatus is used for the quantitative and qualitative study of electrolytic decomposition of electrolytes such as water and hydrochloric acid. So this is the Hobsman apparatus. As you can see in here, we have here the battery. This one serves as the power outlet or power source, external power source. And then we also have here the beaker. And then in the beaker, we have here two hooks or black hooks. So the left hook would be our anode, this one, and the right hook would be our cathode. Okay, so what we're going to do in here, specifically the battery, will then produce an electrical energy or electric current in order to synthesize or to break down water into simpler substances, which is the hydrogen gas and the oxygen gas. So, in terms of the ratio between hydrogen and oxygen gas. So we have here two atoms for hydrogen gas, and we have here one atom only for the oxygen gas. So that is the end product of electrolysis of water. So ayun nga, we need to conduct the electrolysis of water in order to properly synthesize simpler substances such as the H2 and O2 molecules. Okay, so that is for the electrolysis of water. Next, let's have here the Faraday's law of electrolysis. So the proponent of this law is no other than Michael Faraday. Okay, so Michael Faraday is an English physicist and chemist, and he proposed that the amount of electrical charge introduced to the non-spontaneous system is directly proportional to the chemical change produced, and that the quantity of electricity produces a corresponding amount of substance being electrolyzed. Simply, according to Michael Faraday, the amount of electrical charge um, given or introduced to a non-spontaneous redox reaction is equal to the chemical change it produces, as well as the amount of substances produced right after a redox reaction is always directly proportional to the amount of electricity being given off or being acquired from an external sources. So kung gano'n daw karami yung electricity na in-apply mo, ganun din karami yung amount of substances na maaari nating ma-synthesize or ma-produce. Okay, so that is according to the Faraday's law of electrolysis. Okay, so next naman, we have here some commercial electrolytic processes. Okay, so before we differentiate two common types of commercial electrolytic processes, namely electrorefining and electroplating. let's define first what is an electrolytic process. Okay, so electrolytic process is the use of electrolysis industrially to refine metals or compounds at high purity and low cost. Some examples are the Hell-Héroult process used in aluminum or the production of hydrogen from water. Okay? So, yung electrolytic processes daw, ginagamitan natin ng electrolysis para makuha natin yung desired product na gusto natin. So, number one, we have nga the electro-refining of metals. Okay, so by definition, it is the purification of metals by means of electrolysis. So in this example, as you can see, the one that will undergo or the one that will serve as the anode would be the impure copper. So always remember na yung anode, siya yung lagi naapektuhan ng electrical charges from our power sources. Okay? So ang mangyayari dito, apply tayo dito ng electric charges sa impure copper, and then right after that, we're gonna be producing pure substances. And then with the help, it is with the help of our chemical medium or electrolyte, that is a copper sulfate solution. And then our waste product in here would be the impurities that comes from the impure copper. So meaning to say, from the term itself, electro-refining, what we're going to do in here, or our target goal in here, is to refine metals. So from an impure substance, we're gonna be producing a pure substances with the application of electrical charges or electric current. Okay, so that is for the electro refining of metals. Okay, so next we have here the electroplating. Okay, so by definition, it is a coating of one metal on the surface of another using electrolysis. Okay, so in here we have is an example. So this is the electroplating for a spoon. So what we're going to use in here is the electrolyte solution that involves silver plating. Okay, so syempre the one that acts as the anode here would be the silver. Yun yung magbe-break down with the help of our power source or electrical charges from the power source, and then unti-unti yung particles nito maa-add do sa spoon natin, which is our cathode. Okay, so bakit nga ba natin kinakailangan na mag-undergo, or ba't kailangan ng spoon na mag-undergo through electroplating? So number one, ginagawa nitong matibay yung ating spoon, and syempre mas magandang tingnan. And then number two naman, ayun nga, it prevents corrosion. Okay? So that is the process of electroplating. So what we're going to do in here is to break down the particles from our desired metal, and then it will then be transferred to our objects or materials to be plated. Okay, so that is for electroplating. So aside from silver, pwede rin natin gamitin metal for electroplating, is that you have here the gold, the copper, nickel, and chromium. Okay? So, yun yung mga pwede nating gamitin para mas maging matibay or para ma-prevent ng spoon natin yung corrosion. So, paano ba nga, or ano nga ba yung indicators na nag-undergo na ng corrosion yung spoon natin? So number one, if there is a formation of frost. Number two, if there is decoloration or discoloration. Di ba, as we all know, some instances, yung spoon natin, nagkakaroon ng color white, ng color black, or ng color green. So that is an indicator already na nag-undergo na siya through the process of corrosion. Okay? So that is the reason why electroplating is one of the most important commercial electrolytic process that is used industrially. Okay. Next, we have here the voltaic cells as energy sources. Under this, we have the battery as well as the fuel cell. Okay, let's focus muna sa battery. So, battery is an electrochemical cell or series of cells that produce an electric current. Aside from that, battery is also uh, a device that serves as energy storage, and it has three main parts. So we have here the anode, the cathode, and electrolyte. So what is the difference between the three? So anode, if you can still remember, di ba, an ion is negatively charged ion. So anode naman is a negatively charged electrode. Well, cathode, this is from the term itself, cathode. Cation is positive, so with that cathode is also a positive electrode. Okay, so next we have here electrolyte. Okay, so electrolyte, always remember, is a chemical medium. Okay, so syempre, yun yung nag-act as conductor in order to properly transmit electrical charges from anode up to the cathode. So electrolyte most of the time is made up of molten salt or di kaya different types of solution. Okay, so next we have here different types of batteries. So we have two, primary battery and the secondary battery. So the difference between the two is that primary battery has a shorter lifespan as compared to the secondary battery. It is because primary battery is not rechargeable. So it is not rechargeable. So without the cathode process or the cathode reaction with this kind of battery is irreversible or a one-way process only. So, meaning to say, kapag nag-undergo na siya ng cathode reaction, completely, na-use up na natin yung kanyang energy output. Okay? So, that is for the primary battery. Under primary battery, we have here the dry cell, the alkaline battery, and then we also have here the button or this battery. Okay, so for the primary battery, we have here the dry cell nga. Okay, so dry cell is also known as a zinc carbon battery. Okay, so meaning to say we have here the interaction between zinc and carbon molecules. Okay, so with that, okay, so it is commonly used in remote controls and clocks, and then for the lifespan, it can only last up to 3 to 5 years. Okay, so again, this is under primary battery because the cathode reaction for this type of battery is irreversible. Okay, so once na mag-undergo na siya ng cathode reaction completely, na-use up na natin yung energy na nakastore sa battery na to, which is the dry cell battery. Next, we have here the alkaline battery. This is an upgraded version of a dry cell battery. So, ganun pa rin, meron tayo ditong interaction between zinc and carbon molecules. And then, ang kaibahan lang nito do sa ating dry cell battery, mas matagal yung kanyang lifespan because it can last up to 5 to 10 years. And then, commonly, ginagamit natin to do sa MP3 players natin, CD players, digital cameras, toys, flashlights, and radios. Okay, so another thing in here is that meron tayo ditong addition of KOH paste, okay? Or potassium hydroxide paste, and yun yung dahilan kung bakit mas efficient siya or mas matibay siya as compared to the dry cell battery. Okay? So, ayan pakiaral yung anode, cathode, and the overall reaction of this kind of battery. Okay, so next tayo, we have here the button or disc batteries. These are small coin-shaped batteries used in calculators, watches, hearing aid, and other devices. Okay, so if we're to compare it to dry cell battery and alkaline battery, syempre ito yung may pinaka lowest energy output and siya rin yung may pinaka lowest lifespan. Okay? So in here, it involves, ayun pa rin, we have the zinc and then we have here the HGO. Okay? So, or what we call the amalgam. Okay? So that is the reaction between a primary battery. So for the lifespan, again, it can only last up to 3 years of completely usage. Okay? So next we have here the secondary battery. So secondary batteries are rechargeable. These are the types of battery found in devices such as gadgets, which is the smartphone, electronic tablets, and automobiles. Okay? So under secondary battery, we have the nickel battery, the Li-ion battery, and then the lead acid battery. Okay? So in the nickel battery, the one that interacts in here would be the nickel and cadmium. okay, or the nickel and cadmium molecules. Okay, so it is known for its jelly roll structure, and that structure significantly increases the amount of current the battery can deliver as compared to a similar size alkaline battery. Okay, so commonly, the NiCad or the nickel cadmium battery is used for portable computers, drills, camcorders, and other small battery-operated devices requiring an even power discharge. So, since mabilis yung electric current ng battery na to, mas mabilis din siyang na-use up. So, it can only last up to 1.5 to 3 years of completely usage. Okay? So, next, we have here the Li-ion battery. I'm sure that you are all familiar with Li-ion battery kasi ito yung mga batteries na commonly nakita natin sa mga gadgets natin. Okay, so commonly, ginagamit siya ng mga producers in the guide or inner gadgets kasi nga matagal yung kanyang lifespan and then mataas din yung kanyang uh, power output. Okay, so it has greater charge capacity and has greater power output as compared to other secondary batteries and primary batteries. So we have here the reaction between lithium and COO2 or cobalt and oxygen gas. Okay, so with that, we can use this one for our electronic devices, including cell phones, smartphones, laptops, computer, and power tools. And this is rechargeable. And all in all, it has 3,000 charging cycle. And that is the reason why ito rin yung common na ginagamit for the gadgets. Kasi nga, dahil nga mataas yung kanyang charging cycle, mas matagal din yung kanyang lifespan. It can last up to 10 to 15 years of completely usage. Okay? So, paano nga ba natin malalaman na it is completely used up yung Li-ion battery? So, di ba familiar kayo kapag lumalobo yung battery? So, kapag lumalobo yung battery, meaning to say completely na-use up na natin or nag-undergo na through a cathode reaction yung battery natin. Okay? So, next tayo, we have here our last secondary battery or last type of secondary battery. So we have here the lead acid battery. So this is a type of battery used in your automobiles. So ito yung mga natatagpuan natin sa mga electrified scooters, electric bicycle, wheelchairs, marine application battery, electric vehicles or micro-hybrid vehicles, and motorcycle. So, all in all, yung kanyang voltage is equal to 12 volts. Okay? So, ganun ka-massive. Kaya nga, ginagamit siya commonly dito sa mga sasakyan. So, minimum, for minimum 3 to 5 years, so pwede siyang magamit. Okay, so maximum naman natin na lifespan is equal to 12 years. So minimum lifespan is equal to 3 to 5 years and maximum lifespan is equal to 12 years. Okay, so next we have here the fuel cells. Okay, so fuel cells are not batteries. Always remember that. They are voltaic cells wherein the reactants continuously supplied to generate electricity. So hydrogen fuel cells have been used to supply power for satellites, space capsules, automobiles, boats, and submarine. So in this type of cell or voltaic cell, okay, so ang ginagawa niya, it converts chemical energy into electrical energy in order to power up different types of transportations. Okay, so that is for the fuel cell. Okay? So, dahil nga, um, mabilis na makapag-give off ng or makapag-generate ng electricity or continuously siyang nakapag-generate ng electricity, mas madali siyang gamitin or mas mura siya. Kaya ginagamit to ng different kinds of transportation na meron tayo. Okay, so next we have here the mechanism for the fuel cell. Okay, so we have here the hydrogen fuel cell. Okay, so always remember in the hydrogen fuel cell, what we're going to use is the water. Okay, so what the water will then be broken down into simpler substances, producing oxygen gas and hydrogen gas. that will then pump up or provide energy to our different types of transportation. Okay, so always remember then that fuel cells can act as a backup power for commercial, industrial, residential buildings, and in different remote or inaccessible areas. Okay, so that is the fuel cells. Next, we have here the process of corrosion. Okay, so process of corrosion is a natural process which converts a refined metal to a more stable form, such as oxide, hydroxide, or sulfide. For example, okay, so once na nilagay natin or in-expose natin yung aluminum sa ating environment, maaari siyang malapit or malagyan ng oxygen molecules. By that time, we're gonna be producing an aluminum oxide. So kapag meron naman tayong water molecules, we're gonna be having an aluminum hydroxide. And if we're gonna be having a sulfur-rich type of environment, kapag in-expose natin the aluminum, we're gonna be having an aluminum sulfide. Okay, so simply, the process of corrosion is the degradation of materials' properties due to interaction with its environment. Okay, so how can we prevent the process of corrosion? So we can prevent the process of corrosion by means of the cathodic protection. So in cathodic protection, what we're going to do in here is to add a layer of a paint, a plastic, or another metal such as chromium or zinc or zinc in order to coat or to prevent um, the reaction or the direct contact with oxygen molecules and water molecules with our specific metal. Okay, so yun nga, cathodic protection is a method to protect metal from corrosion by converting it to a second metal that is more readily oxidized, such as magnesium. So in here, ang ginagawa natin from the term is a cathodic protection. So we are changing an active cathode reaction into a passive cathode reaction. Okay? So, paano nga ba natin nagagawa yun? Katulad ng sinabi ko kanina, pwede tayo gumamit ng acrylic paint or we can also add another layer of metal para syempre ma-prevent natin yung process of corrosion or mapatagal natin na mag-occur yung process of corrosion sa certain metal na meron tayo. Okay? So, yun nga, di ba, real life application, if we're to compare a gate that does not have a paint versus the gate that has a paint on it, mas matibay talaga yung gate na merong paint or acrylic paint. Kasi nga, kumbaga, pinipigilan nila nito na mag-undergo yung metal natin through degradation or corrosion. Or simply, pinipigilan nito na makalawang or magkaroon ng kalawang yung gate natin. Okay? So, kasi lagi natin natandaan na nagkakaroon ng kalawang or nag-undergo ng corrosion yung metals natin kapag na-expose sila to sa different um, external environment. Okay? So, external factors in the environment such as the water molecules, the oxygen, or di kaya the sulfur molecules. Okay? So, that is the process of cathodic protection. Okay? So, ayan, makita natin that is the corrosion. So, we have here the formation of rust. In order to prevent that, we're gonna be having the cathodic protection wherein we are going to apply a layer of another metal or di kaya a layer of an acrylic paint to our metal to prevent the interaction between its environment. Okay? So next tayo, that will be the end of our discussion. Next, let's have here the instructions for activity. So we're gonna be having here the written works activity. So you need to answer the questions comprehensively. So limit your answer into 5 sentences only. So that will be 20 points. So dalawang item lang naman siya and then essay type of question lang. Okay? So it is to be submitted kasabay ng inyong week 5 activity and then i-turn in na lang sa Google Classroom by May 2023, 11:59 p.m. Okay? So next, for the performance task, you need to list all the types of battery that you use at home, find out the voltage supplied by each battery, and what electrochemical reaction each one uses. Suggest why the electrochemical reaction is used in each case. So this performance task activity will also serve as your final output or your project. Okay, in General Chemistry 2 for fourth quarter period. Okay, so ang gagawin nyo dito, pili kayo ng battery na ginagamit at home, paki-picturean. Okay, so right after that, do sa next box natin, lagay nyo kung ilang volts yung meron sa battery na yon, and then lagay nyo rin kung anong type of electrochemical reaction yung applied sa battery na yon. Okay? So, halimbawa, meron kayong dry cell. So, lagay nyo kung ano yung volts ng dry cell na yon, number of volts. And then, lagay nyo rin na meron dong interaction between zinc and carbon. So make sure to include the cathode reaction, the anode reaction, and the overall reaction. And lastly, the sa last box natin, lagay nyo or explain nyo why did you come up or why did you choose that specific type of electrochemical reaction for each battery. Okay? So make sure to do it creatively since this is your final output, okay? So this to be submitted by May 29, 2023, 11:59 p.m. So next year, the references for today's discussion, and that will be the end of our discussion. So if you have questions, feel free to message me during consultation hours. So that will be Monday to Friday, 8 a.m. to 5 p.m. So that will be the end of our discussion. Let's call it a day. Goodbye, class.